Good morning, class. So I hope everybody had a great Halloween. So to roll with that theme, how many of you guys went trick-or-treating? Show of hands, show of not hands. It's fine, not everybody has to participate. So I know I went trick-or-treating, as old as I may be. Me and my friend Mike went trick-or-treating. Now, when we went trick-or-treating, we realized we wanted to get as much candy as possible without having to spend the whole night trick-or-treating, so we spent the rest of the night eating candy. Now, when it was just me and him, we realized we could only get so much candy before we had to go back and get another bag because ours was full. So we thought to ourselves, how can we get more candy in less time? So, does anybody have any ideas about how we would get more candy in less time? Sure, anybody?
Split up.
Split up by what? Not a bad idea. Anybody else?
That's what I was going to say.
Say split up? Okay. Now, so we kind of took on that approach, but a little bit more complex. What we did was, we figured, all right, what if we got another friend? So me and Mike each got one more friend. By doing that, we increased the amount of candy we had. But because we're greedy kids, we wanted more candy than that. So, what do you think we had? What do you think we did? If we did that in the first place, what else could we have done afterwards to get more candy?
And then get another friend.
Exactly, we got more friends. So each person in the group got one more friend. Now you think that would be enough? No, we wanted more candy. So what did we do?
Another friend.
Got another friend. So every person in the group got another friend. So let's break that down into what we did. So, there we go. Oh, it works. Okay, so it started with the two of us, right? And then what did we do? We each got two more people, right? So, since each of us got two more people, we doubled the amount of people we had, right? So that gave us how many people?
4.
4 people. Okay, and then after that, each person got one more person, right? So essentially we doubled it again. And how many people did that give us?
8.
Gave us 8 people. And then what did we do again? Got more friends. So we multiplied by 2 again, and we got, what? There we go. We got 16. And then one more time, we brought and got more friends because we wanted that much candy. So we ended up with 32 people, okay? And we ate our fill of candy. So, as you can see, this is a lot of things to write down, a lot of things to think about. Now, do you think, is there any way we could break this down to make it simpler? Okay. That's kind of what I expected. Okay, so, there's a pattern going on right now. As you can see, it's 2 times 2, and then we got the total multiplied by 2, and multiplied by 2, and then multiplied by 2. So, if we wanted to, we could write it out like this. And that gave us 32. Okay? So as we see, how many times did we multiply 2 by itself to get 32? Yes?
5.
5 times, right. So we see 2 happen 5 times. So, because obviously your hand's going to get tired if you write this aloud every time. What this is called right here, this is called a common base. 2 is our common base in this case. Then what we see is we have me dropping a pen. We have that occurring 5 times. So, normally, if it was 2 plus 2 plus 2 plus 2, it would be 5 times 2 to get us that amount. Because these are being multiplied, it's not 5 times 2, but 2, our base, to a power, which is 5. And this is the equivalent of this. And this is going to give us our 32. Does everybody see how that kind of works? Okay. So this basically brings us into our topic today, which is introducing powers and exponents. Okay? Smart board today. Okay. So, essentially on the packets that I handed out to you guys, timeout. It would have had packets, but because it's today, I don't time in. So essentially, within your package, you see basically what I explained in a more simplified form, more or universal form. So it breaks down into when you have multiple of the same base, where we see like this, we can raise them to a power, which generally comes to a general rule where it's you have your base times a certain number, which in this case would be n, a certain number of times. So let's try this out. Okay, guys? So, can anybody tell me what the base is in our first example? Okay?
4.
Right, so our base is going to be 4. Anybody tell us what our power is going to be?
7.
7. Correct. So see, breaks it down a lot easier. Instead of having to write 4 7 times, we can write 4 to the 7th power and get the same answer. Okay, does anyone want to try out number 2? Now this is the opposite way around. So, what is our base?
6.
6, right. So how many times are we going to be multiplying 6?
9.
9 what?
We'll be multiplying 6 by 6 by 6 by 6 9 times.
Right, 9 times. So, you said 6 by 9. Right, so we'd have 6 times 6 times 6, 9 times. Forgive me being left-handed. Alright, so, let's move on to our next step. These are some more examples. I could go through them, but time constraints would not allow. Okay? So the next step. Now, that little number, our power up there, is not always going to be positive. Sometimes it can be negative. Oh wait, I'm sorry. Strike that. Alright, so we've all worked with negative numbers before, correct? Now what's one general rule we know? When you have a negative times a negative, you get positive. Alright, now, if you have 3 negative numbers multiply themselves, so if we have negative 2 times negative 2 times negative 2, what would our end result be? Yes?
Negative 8.
Be negative 8. Now, the key term right there is negative. Right here. So we see that when we multiply it how many number of times? An odd number of times, we're going to get a negative result. But if we multiply it an even number of times, we're going to get a positive. Now let's take that idea that we already know and implement it into this new process. When our exponent is even, our product is going to be positive, correct. So you guys are going to fill in positive on your sheets. We can do an example, which is the same as when you're doing this. So we have negative 2 to the 4th. Now we see it's negative 2 multiplied 4 times. And that's going to give us a positive answer, because the negatives here cancel out, and the negatives here cancel out, giving us 2 positive answers, giving us one positive product. And then when our exponent is odd, our product is going to be? Negative. Right. So we see that right here. Now all we did was change the exponent from 4 to 5, making an even number to an odd number. And that gives us one more. So we knew this result right here was positive. Now when you have the positive times that negative right there, it's going to give us a negative answer. Okay, guys? So let's try an example. Alright, so we have our base. Our base is what?
Negative 5.
Right. And how many times are we multiplying it?
17.
Okay, so that means it's going to be to the 17. Negative 5 to the 17. Sorry, did not use this. Alright, so because it's multiplied 17 times, what is our result going to be? Negative. Right, so that's what we want to focus on right now. We're just working on what the answer is going to be, positive or negative. Okay, let's try the second one now. Alright, we have negative 1.8. And how many times does it multiply? 122. That's a lot of times. So, don't get too confused, don't get too worried. Let's think about our rule. Odds and evens. Okay, so 122 is what? An even number or an odd number, guys?
Even.
Even. Right. So, what does that mean about our product? It's going to be?
Positive.
Positive, right. So let's focus on that. We want that. It's going to be positive. Okay? Alright. Now, what we've been working with, they're called monomials. Monomials are as you can see, who wants to read it for me? If anyone, sorry about that. Chip, go ahead.
Okay. A monomial is a number, variable, or product of a number and one or more variables.
Right, so, as you can see our example on our sheets, a to the b or a to the c. Now, when you multiply two monomials with the same base, you can add together the exponents. Okay? So here's our example. We have 3 squared times 3 to the 4th. Now we can break it down how we normally would before we started learning the lesson. We're going to 3 times 3 times 3, 6 times to give us 3 to the 6th. Now, as we saw, broken in parentheses, we have 3 squared here, and we have 3 to the 4 here. Now what we can do is, because they're all the same, we can combine them under one parentheses. And then it's 1, 2, 3, 4, 5, 6 times, so we get 3 to the 6th. Or, we're using our rule, using basically the rule where we can add our exponents. We have 3 squared times 3 to the 4, gives us 3 to the 2 plus 4 power, which gives us 3 to the 6th. Giving us our general rule right here, which is a to the b power times a to the c power equals a to the b plus c power. Okay? Let's try an example. I'll only do like 2 of these. Okay. So, who wants to try the first one? Okay. So it's 2 to the 4th power times 2 to the 1st power.
So it'll be 2 to the, you said the first one was 4?
Yeah, sorry about that.
4 plus 1.
Okay, and then what does that give us as our answer?
So we get 2 to the 5th power.
Perfect. Alright, does everybody see how that works? Any questions? Alright. Alright, let's try this one now. This one, our bases aren't, this one, our bases aren't numbers, but it's a variable. In this case, our term is x. There we go. Zoom in. Just thought about that. Easier to see, everybody?
Yes, thank you.
Okay. Alright, guys. So who wants to give this one a try? Okay?
It would be x to the 3rd power plus 3.
Right. Because we have our common base here, which is our x's, and then we have our 2 exponents right here. Okay, and then what does that give us?
X to the 6th.
Correct. Okay. Let's go down there next step. Okay, let's try this one before we go on. Basically, this rule applies just like when we add positive and negative numbers. It works the same way with exponents. So we know that our, because you can't see right here, but the rule is on your sheets, a to the b plus a to the c equals, this to the c. Okay, so if you guys ever have any doubts about it, always look back to the rule that I have on the page for you, okay? Now, keeping that in mind, let's try out number 4. Number 4 is a little bit trickier than the first 2 that we did, because as you can see, we now have a negative number in our exponent. So, who thinks they might know how this one works? Sure.
You follow your rules for adding integers. So you would
Okay.
have a to the negative 4 plus 2, which would give you a to the negative 2.
Correct. See, so as long as you stick to that rule, it's a universal rule that will work whenever you have 2 monomials multiplied by each other. Okay? Now, turn the page on this. Oh, I ran through this actually a lot faster than I did first.
Fine.
Alright, so, this is the candy conclusion, guys. If you want to take a sheet of paper, you can try this one out. Alright, so it's not gonna, basically, at the end of the night, when we put together all of our candy, we split it up amongst ourselves. Some of us like certain candies, some don't like others. I personally like Reese's. So for me, When we dumped all of our candy out, I snagged all the Reese's. So, the thing is though, we started with 2. And we were able to get 31 friends. Okay? So, we need to, first I want you to determine what power it was that got us all those friends. Then I want you to tell me how much candy I would receive if I got 10 pieces of candy from only half the kids. Okay? So take a second and try that one out. Yeah, so let's pretend some time rolled by. Did anybody come up with an answer?
Did you get 160 pieces of candy? Look at that, no.
I believe I did. How did you come to that answer? What was the first step?
That it was 2 to the 5th.
Okay, how did you
because
get that?
There was 31 friends, but including yourself, there's 32 people.
Right.
So 2 to the 5th is 32.
Okay. So you said 2 to the 5 is 32. So everybody sees how we got that? 2 to the 5, it's because it's 2 times 2 times 2 times 2 times 2. So we get 2 and then 4. And everybody knows their powers, right? What comes after 4?
8.
8 and then?
16, 32.
Okay. Perfect. So, okay. And then the next step you did was?
And then it says that you receive 10 pieces of candy from half the kids, including yourself. So half of the people would be 16. So
Right.
you receive 10 pieces from 16 kids. So it's 16 times 10, and it's 160 pieces of candy.
Perfect. There we go. Right. And it's only November 7th, and it's all gone. All right.
Good
So
job.
that's all fun.
Great. And your discoveries you made, you were able to make your print bigger, because that was the first thing that I saw, was the print was so small.
Yeah.
But you suddenly discovered you made the print bigger, and then it was
Yeah, I could've
acceptable.
done that.
There you go, exactly. See?
Yeah, because it caught me, because like when I did it, because I presented this one in Dr.